So in this slide deck, we're going to look at applications of JFE rules. So in the JavaScript Fact Engine, we want to know how these are done, why we're doing it. This is a discussion on why you would do this, along with the demonstration of using rules to do derivation and constraint enforcement in a running sample application. So the question of when to enforce a constraint is kind of interesting. The first thing you think of, well, a constraint should be enforced all the time, right? Well, that is definitely true if you have full data for the application. So we have data in the database, but do we have full data the rest of the time? No, very rarely. Most physical implementations, you'll only have a partial set of data. So certainly if you're on a web page, you don't have all the data for the application. So when do we enforce the constraints? Well, you need the data that you're enforcing, right? You need often the surrounding data. So if you're enforcing a uniqueness constraint, you need a lot more objects than just yourself because you want to know something's unique. And you need to actually write the data, right? If you're not writing the data, it's a complete and utter waste of time to verify the constraints on the data because you know the data you retrieved coming from the database is already validated and constrained data. So a good example of this is the user object, which usually has a required password, or if you're secure, a password salt or some sort of information that will let you validate the password. So on other parts of the application, when you're not editing the password, you really don't need to see this, right? In fact, you shouldn't see it. But the password's required, so if I put a constraint on that says, hey, enforce everything in the model, including the password required, I won't be able to get any data saved, right? Because I will always have an error because my current user object will always be missing its password. So that's a rather extreme case, but it's pretty common to be in that situation where you have some information about an object, but not all of it. In fact, that's what you want for performance reasons and also often security reasons. So unless you're writing the data and you have the data, and you have sufficient information to validate the constraint, there's no reason to turn on constraint enforcement for a specific constraint in a specific page. So the answer to the question is, should constraints always be enforced, is no. You only want to enforce the constraints for data that you're actually modifying directly on a page. So the question of how to enforce a constraint, meaning what is the manifestation of your constraint enforcement, is quite important. And it's not just as easy as, hey, this is really obvious. Completely depends on how the user and the programmer want to interact with that constraint data. So of course, the first thing you can do with a constraint violation is ignore the thing, right? This is normal. If you are not editing the object, if you're never going to introduce a validation error into the model, there's no reason to enforce. Your second approach is just block the thing, right? So sorry, I'm going to stop you from making that change because it introduces a validation error in the model. This is a really bad approach to user interface design because you stop the user from typing something, and users tend to get really anxious and a little upset and start throwing things if they can't type into their web page, right? However, for a database, this is standard operating procedure, right? You get data that's not allowed, it gets a violation, it says go away, and it throws the data out for you. So your third option is to record, meaning I'm going to keep track of what the errors are in the system. Well, the easiest way to do that is to create additional objects that store the error state, right? Because now you have one system. You don't have your normal objects and your error objects. You have everything living within one data representation. If you have errors, of course, you don't want to allow the save, right? So to do this, the easiest approach is to have like one global, hey, I've got error state on here, and that one singleton object relates back to the other pieces in the model. And your last option, which is actually frequently comes up in ORM, is just repair the thing. So I have a subset constraint. B can only be specified if A is specified, right? Well, if I turn A off, just go turn B off. It's not allowed to be there. So that's your other option, is to go ahead and repair the constraint if possible. So that can be done with subsets, exclusions, this sort of constraint. Just go in and fix it. So the rest of this presentation is going to be a screen share live demonstration of a PUS model. This was a partial model that we added JFE markup to. It also has a hierarchy in there, but we're not using the hierarchy in this demonstration. Here we want to look at derivation rules that we need to add to the system. So that's one set of rules we'll be adding. We also want to look at non-structural constraints. So what do I mean by a non-structural constraint? Well, if it's part of the JFE structure, like the functional uniqueness, you have a single, a functional relationship, I don't need additional constraints for it. I can't actually store something that violates that structure. So identifiers, for example, are mandatory. You can't store the object without an identifier. Other parts, like a property, right? If you have a single property value, like a name, and the name's required, well, that's not structural, right? I can create the object without the name. So in that case, we have a constraint that we actually want to enforce. We'll look at the error state pattern, where I create an error state object which attaches to other objects in the model. That'll be all done in Norma Pro. On leaving that, we'll take a quick glance at the files that are generated and a very quick overview on how those are actually used within the application. Then we'll switch to the Angular application, and we can look at this in action. There are a couple utility pieces in there that we'll look at. One is generating interfaces, so you get compiler help and TypeScript help when accessing these models. And then we'll look at the rules actually being applied in action and updates to the UI in response to data changes. Okay, this is Norma Pro inside Visual Studio 2022. This is the model that I was provided with some rules in it. So this is a subset of the PUS model. I used to remember what PUS means, but I don't know right now. So it doesn't really affect what we're doing here. Anyway, when you look at this, we have a hierarchy colorization overlay on it, so you've got a little bit of confusion here, or if you're not familiar with that, it's not really confusing. But, and then we have a number of groups that were added by, well, not by me. So some of those have colorization. These are marked as derivations. And most of these derivations aren't all that hard. These are actually opposite. So if we look at that, it's a standard. It's not a standard. Okay, what that means is if these are enforced, then that's actually implied, right? Because it's going to be one or the other. You're either standard or you're not. Similarly, here we have a mandatory constraint on the service type ID. If your service type ID is 1 to 27, you're standard. Otherwise, you're not. Okay, so again, this constraint is actually enforced by that rule. So in JFE, these are actually not implemented as subtypes. They're implemented as one-to-ones. Why? At the moment, JFE does not support dynamic tracked changes to your subtype. So the subtype can actually dynamically change when you're in a load situation, but it's not done in the rules yet. That will be done with a more advanced typing system. Right now, the typing system is based on JavaScript, which is single inheritance. So I've got plans to extend that. It's really not usually a major problem, but in this case, where we're actively changing the subtype because it's derived, we implement these as one-to-ones. So if you look down here, you have a one-to-one JFE markup on the relationship. So you have a supertype role, you have a subtype role. One site has an as service type. So standard service type will have an as service type property. A service type will have a property called as mission specific service type. And you can navigate back and forth between the two instances. So you can do this on any subtype. You don't have to do them as subtype declarations. but it's necessary if you're actually actively changing the subtype, which happens here. Okay, so to talk about the rules on here, I've put a demo together. Let's change some of the coloring here. This is just a copy of the same application, but nothing generated out of it. Let's turn off the active hierarchy. So now we're back to default normal colorization besides those. And now I'm going to get really extreme and turn off, just de-emphasize the entire model. Okay, so the first thing we need to apply rules to is the derived state, right? The derived state we can now put back on to all diagrams, and we can see that. So this looks like it did before. Right. Okay, so the other thing to notice here is it's a good idea to click on these, and you can look now in the norm of verbalization and see where they're used. Okay, hey, this is used by another derivation. Right, so that's actually used by this derivation, which relies on that. Now this is a trivial derivation. It's just a negation of this one, which also means that the exclusion constraint is implied as well. So with that rule, we have to be careful when we're defining the JFE rules that this fact type derivation is complete before we go in and do this one. What that means is we need a prioritization on the rule, right? So running within a rule frame, we need to say, hey, we better make sure that this one prioritizes before that one. I don't see any other ones here that say anything interesting. At least don't have dependencies on other derived types. So the rest of these are just depending on the subset. So that's clearly one set of rules we want to write. Right? We want to populate these fact types and populate the subtypes. So we can use those. Okay, now clearly in a complete model, these would do more stuff, right? You'd have role players and additional roles attached to these, but this is a small sampling of the full model. Okay, so the next set of constraints we want to look at are what I call the error state. So if these are violated, you have a problem. These constraints can be placed in the model with no problem, right? You can store them in the JFE model, which is really an unconstrained system, besides the structure of many-to-one, many-to-many, right? Your basic structure and the identifiers and identifying properties and links are required. Okay, so in this case, I have a relationship to a name. Well, that's implemented as a prop. So if you look over here, you'll see JFE prop is name. Okay, so there's really no need to implement that mandatory because the name isn't an object that exists. It's just a property value. However, the mandatory needs to be enforced and the uniqueness needs to be enforced. So in practice, we'll enforce that uniqueness by putting an index on it. JFE has an index utility. That index utility has a isDuplicate property on it. So we can look at that property and track when isDuplicate turns on and off to know when we need to create the error. Right? Okay, so this is similar, right? We need a mandatory error here. This is mandatory on both ends, so we need two tracking objects here, or two errors on different tracking objects. And similarly here, right? The service requires the application, the service requires the service type. You'll note most of these are mandatories. Okay, so the other constraints we're worried about are this one and this one. Let's turn those on. And these ones, I've said, hey, we're going to repair these. So why do I want to repair? Well, okay, this says if this is turned on, then that has to be turned on. So what happens when I turn that off? Well, instead of creating another error state object or throwing an exception, I'm simply going to turn it off, right? So if this one is, if this one is unchecked, I have it backwards. If this one is unchecked, then that one must also be unchecked, okay? Notice that this is a derivation. However, by this stage, I won't really care if it's derived or not, because once you pass the rule frame that completes the derivation, all the facts in JFE are treated exactly the same, right? So I just wait for it.
watch it. When it changes, then I say, well, look, if that's off, then this has to be off as well. Okay, and we'll do a little more in the UI to deal with that, which will essentially just disable controls so you don't turn them back on. If you did turn them back on, the rule engine would just immediately turn them back off, so it's not very exciting. Okay, so how do we model this, right? If I go over on this model, you'll see that my default model is the PUS model. There's my model name. And all my JFE types are in there. So if I click on subservice, I have a dash, which just means it has a type in the JFE system. This doesn't have a type because I don't need to for the ID. It picks that up automatically. This will have a link, definition, etc. So this whole model is marked up with JFE markup. Clearly in the future we will automate the generation of the JFE markup and give you a lot more helpers to do that than just custom properties. Okay, so if we look at the error model, what did we do here? Well, my error state, I really don't want to serialize this, right? I don't need it in the JSON. I definitely don't need it in the database. So for now, we're just put it in a separate model. Again, future, we should be able to subdivide the model and decide what goes in the database and doesn't, which is it's currently not an option. We only do multiple outputs at the moment with hierarchies. So you can have multiple schemas defined on a full model or subsets of that model, but you can't do that with databases right now. Okay, so what do we have in here? This is just a placeholder copy of the object in the other model, right? So we have service type. I explicitly put the model to PUS model. I give it a type. Okay. The only thing we're doing here is referencing them. This doesn't have derivation rules or dynamic rules in it right now. And if I click here, I can see that my JFE default model is PUS ERR. This just says don't serialize this. All right. So when I go to JSON, don't serialize anything in this model, regardless of what I say my target output type is. Okay, so how's this set up? Error state is now a type, singleton 1. So the plan is that you'll have one error state in the fact base, and for each of these objects, we create an objectification that points to the error state. Okay, so how do we want this to work, right? When there's an error on the type, we want to create this little objectification. If the singleton error state's not there, we create it on the fly. And then we set one of the properties. So these have corresponding properties on them. When all the properties are clear, you don't have any errors, you delete the error object. When all the error objects delete, you delete the error state. Okay, so using this mechanism, we only have to look at one object in the fact base to say, hey, do I have a problem or not, right? If I have an error state, I want to block save on the system. So this is a fairly straightforward thing. Each of these have JFE props, so I have names for each of these objects, and I can use the type. Okay, so that's basically it for this model, except what do we do and what's generated here? Okay, so in the currently, if you have multiple models spitting, it's really best to separate them by hand. So you'll know when your models change, right? Here we have this basic JFE model. I don't care about that because this is just a small subset of the other one. What I care about is this one, right? Right here, notice, remember in here we'll have depends on, so this says it depends on the other model. So this is your JFE declaration. This is just JavaScript. And you want to load this into the JFE model state if you're using global models, which this project is. Okay, so we have this one we don't care about. This one we want to take and put into another file. Okay, so I didn't generate anything else for this because there's no database, there's no backend, there's no PHP web server, there's none of this stuff is going on through here. The PUS model has a lot more in there, right? So if I look here, there's the SQL, that's the database, 100% generated from the model. Here is the JFE model, right? Looks very similar to the other one. Here's your JFE model. However, there's a lot more stuff here, right? Because this actually defines the full model, not just the objects that we want to put errors on. Okay, this one's a little interesting. So this is what it looks like in TypeScript. These are in JavaScript. These are interfaces of what the actual objects look like. So the JFE model.js is declarative. It doesn't give you the types. It doesn't tell you the properties. This is just a list of what the properties look like. Null goes to a string. Okay, so here's your full definition. Now these aren't typical classes, right? You're not putting anything in the constructor. You're just creating a function, and then the JFE engine takes care of creating these. So this is the raw specification that JFE uses to create on-the-fly implementations of these other interfaces. So if we look at interfaces here, we have a namespace. I can use these in TypeScript. I can now get a full services collection identifier. Notice the ID is required. The question mark means nothing else is, right? It's a very loose system. Unless you add constraints with a rule, you're going to have a loose system. But this gives you a way to read the objects. And notice here, if you're not familiar with TypeScript, this says this is a keyed collection. So I have a key of identifiers that points to this service object. There will be another interface here for the service object, right? Okay, so the problem with this is if you get into Angular and want to bind on this, and right now that's the UI I'm using, it doesn't do any good. All right, why? Well, Angular deals with arrays. It doesn't deal with keyed collections. JFE runs off keyed collections. So if you want to use this heavily in an Angular application, you want an array there, right? So we generate a different set of types. So you also have this Angular ng interfaces piece right here, which will have a different definition. So here we have an array. Okay, so the Angular service which uses these definitions also wraps these types, right? And this is the very, very important part of this. JFE is a data framework. It's not a UI framework. Most of the time in UI, you update things based on, well, some user did some action and we're going to look at the event and guess that, well, because this is related, we may want to do that. Well, it's really a lot easier to just know when your data changes and update the application based on the data. So the Angular classes that look at this are turned off for automatic update. All of the updates come from looking at changes to the data. So what the Angular wrapper does is takes the internal objects. One, if you make a change to a property or a functional reference, it automatically pushes a transaction so all of your rules run. And then you can look at the change to the data. It compares what it was used to what was changed. If something's changed, it redraws the component. So you get a really, really smooth UI development experience, right? Also, a lot of pieces that you really don't want to validate through a view, which most web applications validate through the view, are done at the data level. So, for example, is the field required? Right? Well, most web apps you go to, the little star on the thing will be, well, it's empty, it's not there. But it's not looking at the data. The data's dumb, right? It's looking at the fact that there's nothing in that field. Well, with JFE, you're actually running it differently, right? It's the validation, the majority of the validation is done at the data level, not at the UI level. So you have smart data and a dumb view instead of a smart view and dumb data, done very, very intentionally. This also means that I can update state outside of the part where I'm actually editing the application. So it's much easier to do things like track and undo stack, give you undo redo buttons, give you a save button, all these things that turn on disable or go to an error state, right? Save button's disabled if there's nothing to save and if there's a current error state, or either one of those, right? So all of these things are easier if your data is smart. So this gives you a smart data. So the problem is, of course, when you're into Angular or in TypeScript, you really need these definitions to make it a reasonable editing experience. So this produces them for you. However, and we'll get to this first when we go to the application, this is missing something, right? We defined an errors collection. right? So now I don't have an application process. There's no .errors defined. Why? Because it's in a different model. So we'll address this problem on the other application. Okay, so what else do we have here? We have the JFE model, which is paramount. That's what defines the JFE model and is the input to the runtime engine. We have the database, which is, of course, important on the back end. And then we have two more model or files here. So this is a Doctrine2 markup for a PHP system. Why PHP? Because the first time I did this with PHP, we'll get other systems in there as well. I'd like to do a .NET Core one probably next. But it's very similar. The majority of the inputs are the same, right? Okay, so this tells you how the pieces of this data relate to the database. This is a relational mapping system. You create entity objects. It writes to the database. It's also back-end agnostic. It doesn't really care whether you have Oracle or SQL Server, etc. Right? It writes them all very similarly. All right. Okay, so that's this is a small model, but you still have some code there. The next file is very important. Right? Is your PHP file. So this is the I/O. What does this do? It reads and writes to the relational mapping model, which then reads and writes to the database. Okay, so this is significantly more code. This takes the JSON, reads everything in there, and sets it up. So one of the most interesting pieces here, just to look at it, do we have a order on here? Load order. Okay, so notice this isn't sequential, right? But this determines which objects require other objects. So this is an application that has auto-generated identifiers. If I'm going to reference something, I need its permanent identifier. Okay, so here we have these two don't depend on anything else. These two will depend on the thing at 1. These three will depend on the thing at 2 and 1 indirectly, right? So when you get into larger applications like the ORM model, I believe, has 8 or 9 levels here that are synchronized in order. This is very important when you're doing automatic identifiers because you have to get the pieces to the database to get the right identifier to push in. And we'll discuss identifiers in JFE and local versus permanent identifiers in a different slide deck. Okay, so those are our main files, right? These two PHP files plug in as is into the PHP backend application. The interface files are used in the Angular application, not the PHP side. So basically, Angular is doing the UI, and the data service is done with the PHP. So those are the files we'll be using. Okay, so now let's go to this application. Before I show you that, which I just flashed on the screen, let's look at one more piece here. So in this TypeScript dialog, this is running the same generators that are on the other side. We can either pick Angular wrappers or JFE wrappers. So let's take Angular wrappers. This time we want the error objects. Right? So if I copy code, let's move that on screen, paste Notepad, and go back, you'll now see that along with services, I have an errors object. How does this do this? Well, it's the same application. This is actually running against the JFE model loaded in memory, right? So I can now use this, plug it into my Angular application, and reference the errors objects, right? So this is pasted into the application over here. Here's the PUS model here, and I have both the raw JFE API and the Angular API posted into here. Okay, or pasted. Okay, if we look at our service types page, which we'll do quickly, and if you look in the component, I'm going to look at errors. All right, so here's one way of using the errors, right? You'll notice here there's nothing smart about this UI at all. This says, if my selected subservice type has an errors object, then show an error mark on the UI. And the title, which is your tooltip, says, well, if you see the missing name property, give me that readout, etc. Right? So it goes through and says these are the properties I care about for this display point. That part's not important. What's important is this. Right? That's it. Okay? I'm not making a smart view. All of the data is in there, and it's tracked. Right? So while I'm editing, if this errors object suddenly pops up in my model, then the UI changes course to correspond to that, and I have an error mark in the title. Right? So similarly, on all of these, they're using the JFE API, or the JFE Angular generated interfaces, which are just wrappers on the backend objects. Okay, so let's go in and actually look at the application. So the only thing we're doing now, this is really the full app, or the service types. This queried the backend. Here's the data backend. Query, this goes to the running PHP server. And this is what we got back. Okay. It's actually the return data. So I have a service type here. My save button is disabled. I have no undo redo because I haven't changed anything. And I have a service type. So there are no errors in the system, which is as expected, right? It doesn't come back. Okay, so let's look at a couple things here. Notice this is disabled. This will remain disabled. I'm just following what the application said. The application said that is a derived subtype. Let's go back here. Right. So we're looking right here. It says right there. So this just said this is the opposite of the other one, but it's treated as a derived fact type, so you can't set it directly, right? However, if I change that, that changes, and notice that this one turns on. Right? Why is that enabled? Well, because I have to have that true in order to set realization as part, right? Okay, now I can, because that's on, I can now click this, but if I turn this off, watch what happens. Oop, we go back. That disables, that removed the check, which happened automatically from the rule. And we go back there. And we have an undo redo stack because this is a JFE app, so we get a full undo redo stack automatically from the edit context. Okay, so let's see another one on these. So here, if this is checked, boom, then that's disabled, right? Okay, that comes from this rule up here, right? Which gets down to if I have to check that in order to enable that. Okay, since that is off, I can't check that. So similarly, I can check that. That turns back on. I can check it. And when I turn this on, note that that turned off. Okay, disabled and off. Because that can fact type is now false, right? I cannot set that value. Okay, so similarly, I can add a new service type here. Add a new service type, then I'm going to get a whole bunch of errors on it. The name's required, the ID's required, the scope's required, etc. Right? If I put in call this one premium as well, now I should have a different error. Right, now I have a duplicate error. They're both going to be in the list. All right, so let's undo that. We don't need that error. Let's give it select that one and give it a discount. Got a premium and discount. Okay, now we still have errors, right? Service type ID is required. Okay, so let's give it an ID. I have no idea what these mean, but let's give it an ID of 190. Some scope, and let's see how we're doing. Now clearly the UI could be, we could have tick marks in other places. I just put them in one place here. We need a subservice type. Okay, so now we add a subservice type, and now the subservice type has errors, right? We need the scope, my scope, and we need a name, my name, and now look, all the errors are cleared out. And magically, if you look up here, the Save button also re-enabled. Okay, so I'm going to look at a smaller save. We don't need to look at JSON here. But given this object, okay, now I'm just here. If we go back at the definition, our service type ID determined the type of the subtype. Right? So if we look right here, mission-specific service type, right, that has the same ID as the service type, right? So this is the subset with the one-to-one reference implemented as a separate object, right, instead of as the subtype. Okay, so that will change to a standard service type if I change the service type ID. So let's just go ahead and do that in the app. I can go here. Let's change the service type ID to 100. Okay. And now my save button's happy, right? Because that's valid. Behind the scenes, I've now created a different subtype. In fact, we can actually validate that. I hit save. I'm going to go retrieve my data. And now I have a standard subservice type instead of a mission-specific subservice type. So that's all happening automatically with a single property change in the UI. No other UI work involved. We've made the data smart with the JFE rules. Okay, and of course, even though it's saved, I can still undo it. All right, save again. And if I refresh this, I'll be back to where I was. Mission-specific service type. Okay, so one more brief look. We mentioned that sometimes you don't want rules turning on, right? Usually it's a good thing, and it's not always a good thing. So what this gives you, this is a browser hooked into a backend controller called the Direct Query Controller, which is taking JSON queries based on the model, reading them with the generated JFE.io file, which goes to the relational mapping layer, which goes to the database and gets you your data back. So normally in a final application, you probably don't want to have a direct query open in your app, but for here it's kind of useful. So let's look at a service type. This gives you the directives that are available. So here I can say $* means all the properties. Okay, so I'm going to go in. This is JSON. I need PUS. I need, notice it's being validated. I need service type. And then I need, tell me all the things you want to retrieve. So I'll just get the properties. Okay, so this is your specification. This says what to retrieve for this. And the root identifiers give you a starting point. A null identifier is everything. Get all of the service types. Service type, and we'll go null. Okay, my star went away. I now have a valid piece of JSON. These you can format, do whatever you want to. Make them look pretty, right? Okay, so at this point I can execute the query. And we're going to look at what came back. So this just says, go back to the database, take all, starting from the service type, give me all the properties for every service type. Let's see what happens. Q query, let's see what we got back. All right, so we got one object back. Service type 0. There's a $$ means identifier. Name, service scope. So anyway, it's a valid object. I got my pieces of data back. However, it's only valid on the properties, right? Let's go ahead and look at the JFE browser and see what's going on here. So, oh my goodness, I have an index. I have errors. Why do I have errors? Right? I have a mission-specific service type. I didn't see that in the result JSON. It's not there. Okay. And now we can look at the instance. This, by the way, the plus is a different fact base that is tracking the selection within this page. So you can go back and forth when you start clicking around these. Okay, so there's my object. There's my service type. Hey, I also have an errors object. Right? This runs on any fact base. Well, there's the missing subservice type, and there's the state. Right? So the state is just the ID from the error object, right? So I have one service types collection on my error state object. There's the error state. It's missing a subservice type. Okay, well, what has happened here? Well, the loader ran under a transacted context on an edit context. It loaded the object in, including all the errors. So ran the rules, created a subservice, a subtype, because your your identifier is at 200, so I know your subtype. So it creates a subtype object, creates the error object, creates the error state object to house it, sets the missing subservice type property. It's all of this for you because you ran and retrieved your data with rules in place. Okay, well, you probably really didn't want the rules running here, right? You just want to see your subservice data. So this is kind of a demonstration of why it's kind of important, right, to carefully consider how your rules turn on and off and when they run. Now, JFE does have a policy mechanism in the rule engine. So you register a policy token with the rule, and then you can turn that rule on and off with a callback that says, is that rule enabled at the moment or not? Those can either be filtered dynamically, or they can actually be filtered when the model space loads, which is when your typing system loads, so that the rules are just not there in a given fact base. So it is, we do make provisions for that, but mostly it demonstrates the point of why you have to be really careful about turning rules on, right? In this case, my data is perfect, right? This is my service type. Here's my information. Okay, but the system I loaded it into says, well, wait a minute, the service type requires a subservice type, so I'm going to throw an error for you, right? I'm going to create this error object and say you have an invalid service type. Okay, that's the display part of this. I guess I can show you one more thing. So here's the back end on this. And here are your files. Okay, you'll notice these are very small files, doctrine service. All this does is load this file. This came straight out of Norma Pro. That's the generated file, unedited. In this directory, here's your IO file, which reads the JSON and produces JSON. The JSON read, by the way, is a state change, so it's not the full data. It's the incremental change that you want to apply. And here are your controllers, so that's actually where the interesting work happens, right? Controller, let's look at Notepad on the PUS service controller. Okay, so all this was done. This is the full application, basically, right here. This is what I had to write to make this work. The import JSON will write any piece, so this application has one write input. And here's the request that we were doing to get the service types back. So this basically says, here are my IDs, get all of these things out of the database, return them.
So that's it for this deck. I hope that gives you a good idea of the power of what the JFE rules can do, and the relative ease that lets you integrate your data in with an application and keeping your data fundamentally sound at the same time.